what is the magnitude of the free fall acceleration? Magnitude of the free fall acceleration at a point that is a distance 2r above the surface of the Earth, where r is the radius of the Earth. So what will be the magnitude of the free fall acceleration at a point that is a distance 2r above the surface of the Earth? How much will be the gravity?
1/4.
Read it again.
What is the 9/9?
1/9. What is given? The radius or the altitude? What is given? The radius of the or the altitude? If it's 2 radii above the surface of the Earth. 2 radii above the surface of the Earth. You are not counting the radius of the Earth. What is given is the altitude. How many radii will be from the center? 3. How many times will be the gravity less? 1/9. So will be, what will be the answer? 9.8 divided by what? By 9, correct? Good. And question 7 is related to the same thing. But okay, 7. 2 satellites. 2 satellites are placed in geosynchronous orbits. Orbits with a period of 24 hours, where each satellite hovers over a spot on the Earth equator. Satellite B has 3 times the mass of satellite A. The question, what is the relationship between the magnitude of the gravitational forces of the Earth on the 2 satellites? What will be?
D.
What is D? First look at the formula for weight. They said that the mass of the satellite is 3 times, the mass of B is 3 times the mass of A. Yeah? And if they are in the same orbit, correct? So how much is the weight? So have to be only on what depends? On the mass of the satellite. So how many times have to be the weight behavior? If it's in the same orbit? 3 times. So you're right. So the answer should be D. There are not many questions here on gravitation. There are more on, but basically this is the first part, like where you have to compare things. Then, okay, the next topic. The next topic is I will bring another one where you will work, another where you will answer more questions on this part. All right, the second part is orbital velocity. Orbital velocity. Orbital velocity is the velocity of the satellite in a specific orbit. So, when the object is moving like this, let's say that this is the Earth, this is the satellite on this orbit. We want to get the speed of this satellite. Sometimes, I mean, if we send a satellite, so if we don't give enough speed, that doesn't overcome the gravitational field, and it will land in a certain place, like a rocket. Ballistic rocket, you send, doesn't overcome the gravitational force of the Earth, and land on a certain place. So if we give more speed, it will go like this. If we give more speed at a certain time, we can inject on the orbit. That process is called injection in the orbit, like the International Space Center is injected in a specific orbit, the International Space Center. So if you look in a clear day, you will see that the brightest spot on the sky, that is the International Space Center, which is about 300 kilometers from the surface of the Earth, which is at an altitude of 300 kilometers. So this, let's say that is the International Space Center, a satellite, and it's injected in the orbit. We want to find what will be the orbital velocity of that satellite. That's what we want to find. Because we know that Fg, as I said, is equal to Gm over r squared, but also is equal to mg, but also is equal to mv squared over r if we consider that is a circular path. So we can find the velocity in the orbit with this equation and this equation, or this equation and this equation, depends on what is the given at that location. So how to get this? If I just pair these two equations, I get that v squared is equal to g m over r. This is over r and this is over r squared. So the mass of the satellite cancels out, is independent of the mass of the satellite. And now this square cancels out with this r, and I can get that v is the square root of gm over r. This is the formula to get the orbital velocity at a specific orbit. So let's say if this is the International Space Center, which I said that is a 300 kilometers above the surface of the Earth, the radius, or the orbital radius, will be 608.30 plus 300 kilometers plus 300 kilometers. This will be the orbital radius. The total orbital radius is the radius plus the altitude. You will insert this here in meter. You will insert the mass of the Earth, and you will insert g to get the velocity at that specific orbit. That will be the velocity of the International Space Center. Any questions on how to get the orbital velocity? Very simple. You pair gm over r squared with mv squared over r. Cancels out, you get v. This will be how to get v at a specific location. How can we compare the velocity at two orbits? If this is orbit 1 and this is orbit 2, we just go to this equation and we can set that v squared 2 over v1 squared will be inversely proportional, but now not to the radius, because v squared is equal g m over r is inversely proportional to the radius, not to the radius squared.